Okay, Unit 1, Day 2. Fun situation here. I was in the middle of recording a video and my computer just crashed, or the program recording it crashed, so it deleted the video. So some of this is already filled out, but we'll just go with it. So learning targets, I can define a variable or variables in context of a problem. So we just want to define it, say what it means, and then I can write an algebraic expression or equation from words. So an expression and equation are two different things. That's what we're going to talk about here. So first off, a variable is an unknown or a changing quantity. So it's just something that it varies. It can be, in some situations it could be 5, other situations could be 7, could be 2.5, so on. And since it can change, we just use a letter to represent that variable. Instead of trying to change the number constantly, we just put a letter in to represent it. An expression versus an equation. An algebraic expression is a mathematical phrase, so just a quick phrase that includes at least one variable, and it does not contain an equal sign. So there's no equal sign on this. It's just like a quick phrase, hey you, or yeah, I go with English, but it's just a quick phrase, whereas an equation is a complete, almost like a complete sentence. So an algebraic equation is a mathematical sentence that includes at least one variable and does have an equal sign. Okay, so it has the whole thing. In English, you think it has the beginning, the end, a period, everything. So it has a full sentence. The equal sign is typically, you can tell there's an equal sign when you see the word is. Sometimes they'll say are or was, but is, which can change a phrase into a sentence. So for example, a number increased by 4. So if a number increased by 4, that means some number and you're adding 4 to it. The moment I put is in here, a number increased by 4 is 7, then that sentence, or that phrase becomes a sentence. A number increased by 4 is 7. So that's the equal sign. This I cannot solve for. I have no idea what x is. This one, x is 3, because 3 plus 4 equals 7. Okay? So catching up to where my program crashed. When we define a variable, we are stating that what our letter represents or stands for. So you put x in there. What does x really mean? Does it mean how much money you have? Does it mean how much time it took you? What does it mean? So without doing this, our variable has no meaning. And we want to give it meaning. Any sort of standardized test that you take for graduation, a lot of them will require you to do this. You just have to define what your variable is. So example, define a variable or write an algebraic expression for each of the following. Mark's weight minus 12. So you might be tempted to say Mark's weight, so say m minus 12. But what does m stand for? Well, m stands for Mark's weight. Okay. Otherwise, that could be money minus 12. It could be Molly lost 12 pounds. It could be Monday minus 12 hours. I know I'm kind of stretching on that, but it could be a lot of different things. So here's some practice down here. Define the variable and write the algebraic expression. So the quotient of triple a number and 7. So there's something in there, some variable, and we'll just say n. N represents the number we're talking about. In this case, it's not an amount of money or a time, it's just a number. So you see a quotient. So quotient is division. The quotient of triple a number and 7. So I'm dividing two things. I'm dividing triple a number by 7. 7 goes on bottom, triple a number, 3n. So 3n divided by 7. 2/3 of the amount increased by 5. Well, here's my thing. My variable, a, is an amount of something. So 2/3 of the amount increased by 5. So this amount, I'm going to take 2/3 of it and then increase it by 5. Number 3 is probably one that will trick students a lot. So 1 less than the number of children. So I might say C. C is my variable. What does C stand for? C doesn't stand for children. It stands for the number of children. Okay, so we do want to put in the number of. Now, a lot of students will read this. They'll say 1 less than the number of children. What I just wrote down would be the number of children taken away from 1. Okay, if there's 5 children, I take 1 minus 5, that's negative 4. But if I want 1 less than that, I really want positive 4. So be careful on this. When you see 1 less than, just put minus 1. You're taking 1 away from something. 1 less than something, so I'm taking 1 away from the number of children. Okay, so this one is wrong. We don't want to do that. Okay. Backside. So we got defined variables, right? An algebraic equation. So now we're going to have an equal sign in there. So I'm looking for the word is, or was, or are, or anything like that. So the number of gallons of water used is 30 times the number of trees. Well, I see a couple things here that are varying. I see the gallons of water, number of gallons of water. I'm not sure what that is. And I don't know the number of trees. So I've actually got 2 variables here. So I'll say G for the number of gallons of water, and T will be the number of trees. Okay, so the number of gallons of water used is 30 times the number of trees. So 30 times T. Okay. The number of goats is less than triple the number of rabbits. So here's 2 variables. Okay. Maybe I'll speed things up a little bit. I'll say this is G and this is R. So G is the number of goats, R is the number of rabbits. So the number of goats is 10 less than. 10 less than, so I'm taking 10 away, 3 times the number of rabbits. Okay. And the last one here. So let's see what's going on here. I got my total cost and the change. So we'll say T represents total cost. And I'll say C, yeah, C is good. We'll say C is the change left from $10. So from this I can see that the total cost, let's see, so if the total cost is going to equal 10, oh, wait a second here. No, I want to do the change. I got these backwards. So it's $10 minus the total cost. I was getting myself confused there. So this can be confusing, believe me. So the change you're going to get back depends on how much the total cost was. So you're going to take $10 minus the cost. What's left is the change you get back. So change equals 10 minus total cost. For some students, you'll get them done quickly. For some students, you have to reread it 5 times, and that one right there just tripped me up. I had to read it a few times before I understood what was going on. So, so take your time. Don't rush through it, and hopefully this helps.